Hello everyone, today I'm going to solve LeetCode problem number 1161, maximum level sum of a binary tree. Let's quickly look the question. Given the root of a binary tree, the level of its root is 1. The level of its children is 2, and so on. We need to return the smallest level x such that the sum of all the values of nodes at the level is at level x is maximum. So that means we need to return the level in which the sum of its nodes is maximum. Let us look at this example problem. We have, so this root 1 is at level 1 and the sum at this level is 1, right? So in the second level we have 7 and 0. So in the second level the sum is 7 plus 0 is 7, right? So yes, now the previous sum was 1 at level 1 and the at level 2 it's 7, so that means we have found the maximum sum at level 2. So until now our answer should be 2. And then we move into third level, and then we compute the sum of all the nodes in the third level. Here we have 7 and minus 8, right? So here the sum is 7 minus 8, it would be minus 1. So this is not greater than the previous max sum, which is 7, right? So that means we are not going to update our maximum sum and the level in which we found the maximum sum, right? So here in this case the answer would be 2. Yeah, so for this we can solve this problem using both BFS and DFS. I will use both of this concept to solve this problem. So for the BFS, what we can do is we can make use of queue. We can add the nodes. We first add the root in the queue and we process all the nodes in that label. I mean, like we first add all the nodes in the queue at a level, we process those nodes, and then we move on to the second level. So first we add queue, we add root, and then we process this node. Yes, so it would be 1, and then like we add its children to the queue, and then we first process all the nodes in the second level before we process its children. So yes, so now let's so first thing that we need to do is if root, first we need to check if the tree is present or not. If it is not, then we can just we can just read it. Rated 0, yes. Then so if the tree is present, then we are good to create a queue data structure. Tree node queue equals to new linked list. Yes. Okay, then we first add queue, we add root in the queue, right? Yes. Then we need to define a variable max sum which is equal to the value, because we need to update this maximum sum whenever we find level sum which is greater than this maximum sum, right? So yes, to keep track of the maximum sum, and we yes, so this is the level. We need to define a variable for level, and the main level equals to 1. Yes. Then what we do is we check while queue is on empty. What we're gonna do here, we first need to process all the nodes in the queue, right? So first we have root, we need to process that node, and then we go to the next level, and then we process the children, right? So first we check the size of the queue, and then we also need to define a level sum, which is initially should be 0, right? Yes. So then we loop through the given nodes as less than size I plus. Yes. So now what we do, we take the node out from the queue, right? Yes. Yes. Then what we do is we add the node value here, and then after adding the node value, what we do, we if node dot left is not equals to null, if it is not null, then we add it to the queue. Queue dot add node dot right. Okay, so yeah, remember here I have used the val directly here, but yes, this is because we already checked the root, whether the root is null or not, and if it is null, then we return 0 here. So when we added the root here, that means the root is not null. So for the first time I use the node.val, but I have added the left and right child if only they are not null, right? So if without checking this, the whether the left is null and the right is null or not, then I should have checked it here, otherwise it would have given the null point exception. So yeah, we need to take care of that as well. So yeah, since we checked it here, so I think it should not be a problem. Yeah. Then so yes, so here so we compute the level sum, and then like we add the left and right child to the queue, but yeah, but this child won't be processed until we process the all the nodes in the previous level. So yes, so when we come out of this loop, that means we are done with that level, right? So then what we need to do, we need to check if if level sum is greater than max sum. Then what we need to do, we need to update our max sum level sum, and as well as the level, right? So yeah, I need to okay, yeah, so I also need to increase the level here. So yeah, still, so we check the level sum. If it is greater than max sum, we assign the max sum and also the label here, right? So first here we are label is 1. So yes, so once we are done with the 1 level, then we increase the label, right? So yes, and then finally what we should return, we should return the new label, right? Yes. Now let's check our code. So yes, we're done with this. So yeah, so now here we used BFS. So we can also solve this problem using DFS as well. So here the time complexity is OFL, and the space complexity would be O times OW, where the W means the maximum width of the tree, because we are using a queue here, and then and we are adding the nodes at each level, right? So we are yeah, so that means the space complexity would be the maximum width of the tree. Yes. So yeah, we can also use DFS. So for the DFS, what we can do is, in DFS, what we do, we begin with the root, and then we move to the left, and we go back, and then like visit the right, and then go back to the root, and then like visit right. So using DFS, what we can do is we can make use of a map data structure, and like we can add the label as a key in the map, and then the value would be the sum at each level. So when we are at the root, we add the key 1. Let me use this one. Okay, so yeah, we use a map, and then for first level our sum would be 1, right? So yes, and then when we move to second level, I mean when we go to the left, so at this time the level would be 2, and then we first have 7, right? Yes, and then we move to 3, and then we add it. Okay, sorry, it should be first 7. Yeah, so it would be 7, right? Yes. So when we are done with the left, then what we can do, so yeah, so it again goes to left, it is null. So when it is null, we can just return a 0, and it goes to the right, and we can just return. So in this way, we again go to here, and here in this level, so yeah, so here in this level, so we went to left, and then we go to right. So at this level, so at the third level, we already have a value, right? So we add the existing value, map value, and update it, and it would be -1. We would do the same thing here as well. So it would be plus, and it would be 7, and here this would be 1. So we check the values in the map, and then like if we find a value which is greater than the max, then yeah, we can just pull out the key as the minimum level that has the maximum level sum. Yes, we can do that. Okay, I'm just going through this one and see. Okay, so yeah, so if it is null, we can just return 0, and if it is not, then yeah, we are good to create a map data structure. Map equals to new hash map. Yes, and then what we do is yeah, so we created the map, and then let's create the another helper class here. Max label sum helper. Yeah, that takes the root and the level and the map data structure. So yes, we can call this here. So we are sending return, and the label would be 1 here first, and we're sending the map here. Okay, so first thing is that we need to create a map that keeps the label as a key, and the label sum as its value. So what we should do here is yeah, so if root equals to null, then we will simply write it here. If it is not, then what we're gonna do here, we put the label and map dot get or default, sorry, this is default level comma 0 plus 1. So yes, we first check if the key already exists, then we, okay, this should not be the one since we are adding the value of a node. So yeah, so that should be so if the label already exists, if the key already exists, then we're just going to add it whatever is there in the map. If it is not, then we just add the root value with 0. So that's what we're doing here. And so once we are done with this, what we do, we just increase the label, right? So yes, so when we are done with the root and we added the label and its sum, then we move to its child, right? So we move to left, so that means the level is increased. So then what we do here, we call max label sum, we recursively call this function. So here root dot left comma label, and we are sending the map, and we do the same for right as well, comma map. Okay, so yes, so yeah, we can also check this here. So yeah, we can just only call the recursive function if the left and the right is also not null. So yeah. Yes, so when we do this, we are done with the helper functions. So yeah, once we are done with the helper functions, so our next task is to check the map for its values, right? So for that, what we need to do again, we need to assign a variable integer dot main value, and again we need to to 1. So what we do here, we L3 for entry il map dot entry set. So what we do here, if we need to check entry dot get value, if the value is greater than max sum, then what we do here, we update the value, or yeah, so yeah, since we are just returning the label, we can also remove this one. I mean, we can also ignore this one. If we had to return the maximum sum as well, then we could have done that. So yeah, max level, but yeah, anyway, so max level equals to so if we have found the level sum which is greater than the previous max sum, then we can just get the key here. Yes, and then what we do here, we return the level, right? Yes. Now let's check our code. Okay, we have a problem here. Invalid method declaration return type required. Okay. So since we are not returning anything, we can just do the void. Okay, well, So yeah, so here the again, since we are traversing each node, so the time complexity would be OL, and the space complexity would be O of height of the tree. So yeah, we are done.